Okay, guys, welcome. Today we're going to talk about solving linear inequalities. Um, so it's going to be very similar to when we solved linear equations. The only difference is you now have, instead of an equal sign, you have an inequality sign. Okay, so the rules are almost exactly the same. All right, you can add or subtract. This first rule is saying it. You can add or subtract both sides of an inequality, and that won't change the solution. All right. Now the second rule here says that you can also do the same with multiplication and division, but if you multiply and by a negative, multiply or divide by a negative number, you need to flip the direction of the inequality sign. All right. And just to sort of see a simple example of why you would need to do that, let's just look at the true statement: 1 is less than 2. Right. We all agree that 1 is less than 2. If you multiply both sides by -1, then the number on the left is a -1, and the number on the right is now -2. And of course here, -1 is further to the right on the number line, so that's bigger than -2. So that's just a sort of a simple example to see why. Okay, so let's go ahead and do it. So in the first example, we want to solve 2x plus 5 greater than or equal to x minus 3. Okay, so again, to solve this, all I need to do is I just need to treat this as if it were an equation, with the only caveat being that if I multiply or divide by a negative, we just need to flip our sign. So here, I can move the x over so I don't need to worry about a negative. And let's move the 5 while we're at it. So my x's are being moved to the left and my numbers are being moved to the right. So then we get right away that x is going to be greater than or equal to -8. All right, so now as far as graphing this solution set, somewhere over here I have a 0, then maybe down here I have a -8. And since we have the equal sign, I want to include -8, so I'm going to need a closed circle on -8. And if I want numbers that are bigger than -8, I need to shade to the right of -8. All right, so that's our solution set for this first inequality. Okay, now for the second one, we have 3x minus 2 greater than or equal to 2x plus 4. So this is very similar as before. Let's move the 2x over so we don't have to deal with a negative. And we'll add the 2 while we're at it. So on the left side, we right away get x. And on the right side, we get 6. All right, so it looks like here, if 0 is here and 6 is here, we're going to get something very similar because we still have the equal sign here. So I want to include 6 and have a closed circle on 6. And if I want numbers that are greater than 6, I would need a shade to the right. So I'm going to have something like that. All right, so that's what we mean when we are solving any inequality and then graphing the solution set on the number line. By the way, while we're here, we might as well just note that in interval notation, this would look something like this, because I'm starting at -8 and I want to include it, so I would use bracket, and then I take it out to infinity, and infinity always gets parentheses. Right? And then similarly, this one would be bracket 6 to infinity. Okay, so hopefully those aren't too bad. Okay, let's look at example 2. So in example 2, we have 5x less than 2 times x minus 1. So of course here we need to distribute. We get 2x minus 2, so then I can subtract 2x. And I get that 3x is less than -2. And once I divide, I get x is less than -2/3. So now here, since we don't have our equal sign, so if 0 is here, -1 is here, -2/3 is going to be somewhere about here. Now, since I'm not including it, I use an open circle this time for -2/3. And if I want numbers that are less than -2/3, I'm going to shade to the left this time. So that's our solution for part A. Now for part B, we have 8x plus 2 is less than or equal to 3 parentheses x minus 1. So again, we'll distribute first here. We get 8x plus 2 less than or equal to 3x minus 3. All right, so again, I want to move my 3x to the left so that I don't have to worry about negatives, right? If you were to instead subtract the 8x to both sides, then you would have a negative and you'd have to worry about flipping the sign. But again, so we'll subtract the 2, the same step here. And then these cancel and so do these, and we're left with a 5x less than or equal to -5. So once I divide by 5, I get x is less than or equal to -1. All right, so if we graph this, so 0 is here, -1 is maybe somewhere over here. And of course here we're back to including it, so back to a closed circle, again, because we including the equal sign this time. And if I want numbers, again, less than -1, we're going to shade to the left. Okay, so our answer is going to look something like that. And again, in interval notation, this one would look like -infinity to -2/3, and this one would get a parentheses because we're not including the -2/3. And then, of course, this one, -infinity to -1, but we do want to include it, so we have a bracket on here. Okay, so that's solving linear inequalities. Now, we talked a little bit before about compound inequalities, and if you have variables now in your compound inequalities, or algebraic expressions, I should say, you can solve this one of two ways. You can either just work on all three parts at the same time, or you could split the compound inequality into two separate inequalities, and I'll sort of show both cases here. All right, so in part A, we have -3 less than or equal to 1 minus 2x, which is less than 6. All right, now one option is that we could say, here's one inequality, and here's the other one. 1 minus 2x less than 6. And we could just solve each of them separately. So let's go ahead and do that. So in this one, I would need to subtract 1. Now I get -4 less than or equal to -2x. And now here's where we need to be careful, because once we divide by a negative number here, in this case -2, this will become a +2, this will become a +x, but I need to flip the direction of that sign. Right, and then on the other one, we're just going to subtract 1, -2x less than 5, and when we divide by -2, we get x. Again, since we divided by a negative, we need to flip that sign, and we'll get -5/2. All right, now of course on a number line, if x is greater than -5/2, which is somewhere down here, but 2 is always greater than or equal to x, we saw that -5/2 gets an open circle, +2 would get a closed circle, and it looks like we want the stuff in between them, since we want to be bigger than -5/2, but less than 2. And it also may help to think of this as the equivalent version is x is less than or equal to 2. So that's another way we can think about that. Now, the other option is to notice that I'm doing the same steps on each side, right? First, I would subtract by 1, and then I would divide by -2, right? And I did that in both of these separate inequalities. So the other way to solve this is to do the following. We have negative 3 less than or equal to 1 minus 2x less than 6. So what I could do is just subtract 1 instead of from both sides, I'd do it from all three. And this gives me a negative 4 less than or equal to negative 2x less than 5. And now, when I divide by negative 2, I just have to do it to all three parts. Now, since we divided by negative, these inequality signs do flip. And this is an x, this is a 2, and this is negative 5 over 2. Now, usually we would want to write this so that it goes from least to greatest. So we would reorder this to be negative 5 over 2 less than or equal to x, which is less than or equal to 2. But that's saying the same thing as these two, right? So usually I prefer this method on the right here, just because it's a little bit quicker. But usually the method on the left helps people sort of visualize, what's really going on. Okay, so let's do one last example and we'll wrap this video up. So the last example, I'm gonna make myself a little more room. So the last example we have is negative 5 less than 2 minus 3x less than negative 1. Okay, and I'm just going to operate on all three parts at the same time. So I would need to subtract 2. I get a negative 7 less than negative 3x less than negative 3. So then we'll divide each part by negative 3. And again, since I'm dividing by negative, these all need to flip direction. So on the right, it looks like I'm getting a 1. And on the left, it looks like I just have a 7 over 3. Right, so of course we would want to reorder this so it's least to greatest. So 1 less than x less than 7 over 3. All right, and actually, let me look at this. I think I might have, yeah. I just noticed in the last example that I carried that extra equal sign. So it should be that. Okay, but anyway, so in here, both 1 and 7 over 3, and 7 over 3 is like a little bit more than 2, but both of them are going to get open circles. And since I want stuff bigger than 1 but less than 7 over 3, I just want the stuff in between. All right, so that's our solution there. All right, so that wraps up this video on inequalities. Hope you enjoyed, and I will see you next time.